Hello everyone, my name is Jimin Kim from North London Collegiate School Jeju, and today I'll be presenting my project, a haptic feedback rehabilitation system enabling remote guitar playing for users with limited hand mobility. This project combines my interest in engineering with my passion for music with the goal of making guitar playing more accessible and inclusive. The traditional guitar playing requires coordination between both hands. The left hand forms chords while the right hand controls rhythms through strumming. This creates challenges for three main groups: beginners, individuals with physical disabilities, and people recovering from injuries. My project particularly focuses on enabling guitar playing for users with limited mobility. Although automated guitar systems do exist, they have clear limitations. They rely on often the pre-programmed patterns, lack real-time responsiveness, and fail to capture natural human expression. Therefore, my research objective was to develop a sensor-based system with a control algorithm for servomotor movements to make guitar playing more accessible for a wider audience. And also, I wanted to maintain an affordability of under $150. The system architecture mainly consists of three main components. The first is the use of FSR 402 pressure sensors to place them on the glove to detect finger movement. Second was the processing unit, which uses the Arduino Nano microcontroller, which interprets these signals using a threshold-based algorithm. Third was the actuation mechanism, where servo motors were attached to the guitar, physically strumming the strings. These are the hardware components and the electronics used by the system. And this is the system circuit design of the FSR sensors connected to the Arduino Nano and all the resistors and the servo motor outputs. So for the system software and algorithm, the Arduino will process the signals and activate the motors when the threshold is exceeded. To simulate the natural strumming, the motors alternate between the two angles of 80 to 100 degrees, creating a forward and backward motion. A short delay was also made to prevent unintended repeated triggers and ensure a smoother performance. This is the system control code. And for the mechanical design, to integrate everything, I designed a custom 3D printed mounts. These allow the motors to be attached without modifying the guitar. And also the system is fully removable, preserving the instrument. And the glove was designed to provide comfort for extended use. These are the 3D printed designs. And this is the detailed hardware integration of all the components. And this is the glove. Whilst testing, the system performed quite reliably. A threshold value of 70 successfully filtered noise, and response time was around 50 to 100 milliseconds. The user feedback was also especially meaningful, where the beginners were all able to focus on chord learning while maintaining the rhythm, and the users with limited mobility could play using only one hand or utilizing only one hand. However, improvements were suggested, such as better control over intensity and more complex rhythmic patterns. There are still some limitations. The system currently supports only two basic strumming patterns, limiting the dynamics, and the latency becomes noticeable at very high speeds, and the sensor calibration is required for each user. And also, there is a high power demand where six servo motors are used simultaneously, and the battery life is around 2 to 3 hours of continuous use. And also, it can cause the accelerated string wear through the continuous mechanical strumming of the guitar. Moving forward, further enhancements and applications can be suggested. I plan to improve both hardware and software. This includes replacing the pressure sensors into the accelerometers, or create this wireless-based connectivity and integrating machine learning for more expressive control. And also, I believe that this technology could also expand beyond guitar into broader rehabilitation and assistive applications. In conclusion, this project demonstrates a system that translates hand movement into real-time guitar playing, and it enables single-handed performance, supports rehabilitation, and lowers the barrier to musical instrument. Thank you.